Hey everyone, uh, welcome to this session. And first of all, let me introduce myself. Myself, Aditya Attkan, and uh, I am here, your instructor for this session. I'm currently founder of MLC UIT, working as a full stack developer and also as a cloud developer working on cloud platforms. So today we will talk about Azure. It's some kind of service which will mostly use to basically manage and deploy machine learning models and to design the machine learning models on yourself using Azure Machine Learning Studio. So yeah, we will gonna talk about that, and yeah, let's start with that. Okay, so I guess the presentation is visible right now. So yeah, first of all, welcome to this session to all. So yeah, starting with this presentation. First, we will gonna talk about some about machine learning. We will step by step go through all the machine learning process, and we will morally talk about what things what matters that really matter to we discuss about in machine learning. Then we will gonna talk about Azure machine learning, what Azure provides you in the field of machine learning, how you can use that service provided by Azure to basically create your own models and deploy that models so you can just use them in your web services, web applications, and let others use their your models also. So yeah, let's start with first somehow my introduction. If you don't know me, hi, I am Aditya, and yeah, I'm a founder of MLC UIT, Microsoft Student Ambassador Beta Level, and also the chapter lead of Rohtak for Azure Developer Community. And so here is my LinkedIn. If you have any doubt regarding this session or any other things related to tech, related to community, you can just ping me a chat or ping me a message in on my LinkedIn. So yeah, here is the QR code. You can just scan, and yes, then we will move on to next slide. Okay, so yeah, talking about machine learning first. Uh, I know there are students who have joined us. There are students from first year, second year. There are students from third year, and mostly some are graduated, and some are in fields like AI, ML. So I know that some students have known about basic of machine learning, basic of AI, basically. And yeah, also I told about that there is we also talk about what is there are many AI applications already in the market. We know that there are ChatGPT, and there are ChatGPT have their own services. We have Azure OpenAI, and we have there are several models in that. We have Azure OpenAI Codex, we have Llama 3, we have Gemini for Google. There are many things in that. So basically, we are talking about what is the machine learning. We are talking about a model. We are talking about a computer machine, a computer program, basically, which is which are trained itself, so they can just adapt the environment. They can just adapt the conversation. They can think about them, think from themselves, and just reply back, or just process your request, process the information according to them, so that they can just learn from itself, and like uh, discuss about it and present that conversations, you can say that. And yeah, talking about machine learning. So machine learning is a kind of subset of AI. When we're talking about AI, there are many things in AI. We have some called machine learning. We have some called deep learning, and in the deep learning we have something called neural networks. So we are basically talking about machine learning right now. So machine learning is a something kind. If we're talking about a traditional process, if we're talking about a simple process in a like software development cycle, we know that in traditional problem solving software, a person analyzes a problem and engineers a solution in a code to solve that problem. Okay, in a meaning way, in a simple way, what a engineer, what a programmer do that understanding a problem. The problem says gathering the basically writing the program, gathering the input, and just process that program on that input. So if they can find the output which are desired by themselves, or is the output is correctly generated or not, so they can just ensure that. But in a machine learning scenario, we can see that the problem solver abstracts away part of the solution as a flexible component called a model. So sometimes there are cases that we don't know, that we know that there is a problem, but we don't know which program is suitable for that. We don't know how to build the program for that. to that problem. So we know that we have the problem, we have the data. So how we can make that computer be able to make the code itself for the on the basis of that data. If we're talking about something called if we are talking about simple, we talking about a prediction model. If we're talking about house prediction model, so we know that there is a problem of house prediction. We know that in a particular area there are many houses who have been sold in recent years. We have the data of that particular houses, the data that contains the particular size of the house, the dimensions of the house, the area cost and the house cost, the how much bhk of the house is, where it is located, what the current price of that, what the price are coming up in the next years. In that, there are a bunch of data for that. So we have that data, but we don't know how to if we want to a new house, what price of that house we can just predict based on that particular things, based on particular parameters, we can say that. So yeah, that data helps in that. We can particularly process the data and make programs, make different programs on that data, which we call a model. If you can say see that the problem solver abstracts away part of their solution as a flexible component called a model, and uses special program called a model training algorithm to adjust that model to real world data. Okay, first we create a model using the data. First we perform some perform some cleaning of the data. We will also discuss about the steps we for some easy easy to go things. We have the data, we will some cleaning the data, we have some processes, we will process the data with some models, with some regression model. In this case, prediction model, we know that for the there is a label data. We know that what the output is, we can label that input to the output. So we can say that is a kind of supervised learning problem. There are types of learnings in that. In the machine learning there are 2 to 3 types. We can say that supervised learning, unsupervised learning, and there is a reinforcement learning. So in a supervised learning, we can say that the data which we are providing is connected with the output something. If we can say that if we're talking about this, we can say that the data input data is somehow connected with the output. We can see that that the much that price can be expected from that. So that is a kind of supervised learning. We can see the outputs easily, and we can just make a model on based of that. But in the case of unsupervised learning, we always use unsupervised learning method on that particular kind of problems which doesn't have labels in itself, which does not showing that this data is connected to this output, so we cannot see the patterns. We there's data is in a kind of if we're talking about image processing, if I want that something, the model or the problem have is some kind of image processing. So yeah, if you can see that we know that if image contains a tree, we know that that's a tree, that we are labeling the data, but computer doesn't know. Computer only sees that in a pixels form. So that is a kind of unsupervised learning problem. So in that, what the computer does, what the machine does, that clusters that some same group of data, and predict the data, predict the output on the basis of that. In reinforcement learning, we know that in reinforcement learning, something that we were training a training a person, training a dog. If I'm talking taking about a best or famous example, training a dog. Okay, so how I train a dog? If I'm telling a dog to do this work, if the dog is able to do that work, I will reward him with some things, with some uh, goodies, with some biscuits, with some with that the dog knows that whenever I do this work, I will get this reward, and that work will be correct. So yeah, whenever the dog is not expected to do that work in a correct way, I will give him a penalty, cut out some penalty, minimizing the food and some punishing him, and that kind of thing. So yeah, that kind of from that things, the entity, the object learn try to learn itself, try to learn from the rewards and from the penalties itself. So that kind of learning is reinforcement learning. So in this complete session, we will morely talk about supervised learning method, that is a kind of easy and easy to use method. So yeah, So you can see that we also discussed about model, and we have like model training. We also talked about model training algorithm, use a special program called model training algorithm. There is a bunch of algorithms in there. We have so regression model, we have classification models, model training algorithms, we have unsupervised learning in that, we have reinforcement learning method models in that. So we can just perform that. We can just make a model and use model training algorithm to find a program, and then make that program deployable. So in a real world scenarios, the real data can be able to make that model process the correct output, the correct correct expected predictions, expected output from that. The result is a trained model which can be used to predict outcomes that are not part of data set used to train it. Okay, so yeah, and move on to next thing. So there are a bunch of steps in that, 5 machine learning steps there are. So first step is define the problem. So first step is a basic step. We also can tell it as step zero, but just considering it in a scenario that is most important, we can just say is a step one. So in this case, we first define a problem. Okay, so defining a problem, since first we have to find that problem. Like if I'm talking about the house prediction problem, there is a house prediction. In that case, the problem is like we have to predict prices based on the house circumstances, based on the parameters like house size, house dimensions, area size, area which where the area is located, where the current price is, where the previous price is. So there are some parameters on which we have to just predict, and if a new house, how much a new house costs in that area particularly. So yeah, that's the kind of define a problem. And then we also find some data. So regarding a parameter, regarding data, we also have to find the data and clean it firstly. So yeah, that all things come in that define the problem. Then we have built the data set. This is step second. So in this we have some four steps also, that is data collection, data inspection, summary, statistics, and data visualization. Okay, so in this case we first clean the data. First we have the data, we first try to kind of thing like clean the data, gathering the data set, gathering the data. And firstly cleaning the data means is to cleaning the outliers in that. Outlier something and the data that is not important in this case. I'm talking about if I'm talking about a house like a bungalow, but there is a like in that area there is a house which is not a bungalow, which is a like 2 to 3 story house. So that kind of house is not expected for this problem. We know we want that there must be like area for the bungalows, and we want to like expect the price for bungalow. So what the 2 to 3 story 2 to 3 story building will do in that, so that the kind of things are outliers in that. So we will try to remove that outliers and clean the data, so we can get as much as data, as much as clean and prepare data for our next inspection. Then we have data inspection. We will finding the outliers in that. We have summary, statistics, and we have then data visualization. We will just visualize the data, what kind of data we also get in that. Although we try to divide the data, and we have the data. Okay, so there's a scenario we have to we will divide the data in some kind of ratio, in kind of 8:2 ratio or 7:3 ratio, which is 70-30%. There is a 70% data which is training data, and 30% data which is testing data. So yeah, we know that for like let's say we have a 30% testing data. The testing data is kind of something that we can show that's a correct value. Okay, that output that that output that data is showing is a correct expected nearby expected output. So we can just use that data for the testing purpose. So we can just divide that data into 30%, and we can just take the data for 70% data for our training purpose. Then we have trained the model. Step 3, we just train the model. So now we have the data, we have the training data. Now we will use that training data and use some training models, and just put them in a model evaluation model, and just try to process the data, and thing like processing the data repeatedly. So it's a kind of machine learning is a kind of repetitive process, iterative process. Okay, so there is some case scenario that on in the first outcome it is not be able to find the correct output. Like we have to change the parameters, we have to change the biases and that. So yeah, that kind of repetitive process. Yeah. So in in this thing, we use models like neural networks models. In that, there are a bunch of models. We have linear regression, we have classification models. Yeah. So in this, for this, we will talk about practically. We will talk about linear regression model. Okay, that's an easy one to understand and use in your particular scenario cases. Then we have evaluate the models. Okay, so evaluation means is the, or is the model we will get is producing the correct output as we are desired or we are expected. If not, then this move on, like this is repetitive process. They move on to previous, like train the model and change, try to change the, sometimes change the parameters, sometimes change the biases. Yeah, sometimes change the model itself. Sometimes that model is not suitable for the particular problem, we have to change the model. So yeah, that's iterative process. Once we get the nearby expected or expected desired output, then we can just evaluate the model basis on some testings and then use that model, or we can say deploy the model in the step 5. So yeah, that's a kind of basics of machine learning. So yeah, and what now the say about the session, what is your machine learning? So we have discussed about machine learning. So you know the steps, you know the things we included in machine learning. So what Azure is providing in the field of machine learning, you can see that Azure Machine Learning is a cloud-based platform that helps data scientists, engineers, and other machine learning professional build, manage, and deploy machine learning models. Okay, so in this case of scenario, you are building a model, you are creating a machine learning model on yourself, training a model, deploying a model, and using that model for a web application. You can just do that in a practical scenario using some like Python. You can use that Python language for that. But Azure here is taking benefit of that. We are give Azure is giving a benefit in that we will get some services in this for particularly for your machine learning things. So what things we are getting here is instant compute. We have our own compute system or compute instances for a particular machine learning model to train, to test, or to deploy that model. Okay, you can say that. And we have data storage and connectivity. We have like we will get some Azure blob storages, and we have some connectivities, and we have ML workflow orchestration, model registration management, matrices, and monitoring for that. So there are a bunch of things that Azure provides in the field of machine learning to us as a service to build machine learning models on the cloud platform itself. And on like building these machine learning models on the cloud platform is something itself is a like advanced is like a fun thing, is like a creative thing, is a curious thing about building machine learning models on the cloud platform itself. So yeah, let's go to some practical things. We will just see a model. We have a simple model. So the problem is to like predict the automobile prices. Okay, so there I have designed a model for that. How is able to predict the model prices, how it is expecting to it is it given the desired output or not, how the model is trained, how what models training algorithms we use, what steps we particularly followed. Okay, so yeah, let's move on to portal Azure. Like, let me share my screen first. Yeah. So this is your Azure platform. So yeah, I am also announcing a simple giveaway for you at the last end of the session. We have some Azure vouchers, Azure for student vouchers. So if you want to like go some practical on your hands-on for this, like create some models on yourself, practice this model which I will talk about in this session. So you can just get Azure for student voucher and just do prepare for your prepare on your. So you can just go hands-on on that. So yeah, that makes your practical more strong. So yeah, first we'll like go to portal.azure.com. And yeah, and just like first you have to create a like create a workspace. First we will create a workspace for everything. If you talk about like if you want, I want to create a web application backend service, if I want to perform some DevOps works, if I want to just do anything on the cloud, first we have to create a workspace. So I will create a workspace for that. So I will just search here Azure Machine Learning. So yeah, whenever you open this, Yeah, here you will find some like this is a workspace for Azure Machine Learning, but you have to create your own one. So I can just go and just create a new workspace for that. I have already created one, but let's just discuss about what things you need to create one first. So yeah, there is your you have to select your subscription. There you can select your resource group. You have to create one, or you can just use the existing one. I have existing one, so I can use that. So here is the name of your workspace. You can just Azure ML, or what the problem is, what the model will gonna do. You can just write the name on basis of that. In the region, you can just select South India. I've selected South India because it's nearby for India servers, for India data centers. And storage account, you can leave like, you can use both of them. You can live with default. And yeah, just you need to just add the storage region and your name, and you can just next in that. Yeah, next encryption, you can just set all this by default. You don't need to do anything in that. Okay, just you can do review and create your own workspace. So I've created one, and I can just go and select in that. This will take few minutes to create your workspace. And yeah, I will shift out to my workspace, and now you can see that now whenever the workspace is ready, you can just go and create launch, like click on Launch Studio. I will just share my another screen. So yeah, so whenever you click on Launch Studio, you will get redirected to particularly the Azure AI ML Machine Learning Studio. So this is the complete the whole studio, the whole benchmark. You can say that a whole like work store. You can just go. You can just use that to create your models, to deploy, to manage your models, your machine learning models. Yeah. So here a bunch of things. Here a bunch of menus you have to just know to it. So first menus is our notebook. So notebook, you all know that we can create our own notebooks like in Python, Jupyter notebooks. So we can just create some ML models or test some ML models on base of Python programming language, libraries and frameworks. Then we have automated ML. This is like creating automation ML jobs, like automated ML jobs. You can just create your own ML or whenever you create new model, that particularly automation job will automatically work on that. Then this is the designer. This designer is important. We will discuss about this, like we will create our own model. You can see that there are two models already in the already created. These we will gonna talk about these models. And we will have some like in assets we have some data, and we have bunch of datas here, and we have jobs. So whenever you create a model and submit that model for review, and you for your further processing, the model come under here jobs. And that's currently in your that's currently your pipeline. So you are like making changes on that. So that comes on your like under your jobs. And whenever like also in a pipelines, whenever we are prepared to get deployed the model, that we can just deploy that pipeline itself on the to use in the web applications itself. Then we have some models. Here you can find the models already. And we have endpoints, and we have like compute monitoring. Yeah, the bunch of services in that. So first of all, what you gonna need to do whenever you launch Studio. So first, go to compute clusters, and here you have to create a new compute cluster on which you are gonna make your model. You have to use some resources. You have to use some remote resources, some remote things like processor compute power and RAMs for to process to basically manage your notebooks and manage your data on that. So I will just go and create a computer cluster in that. So location is South India. I will use South India as I have already used before. So yeah, basically leftover by default. Then you can use there are a bunch of CPUs already provided. You can use as the base of your need. But I will just go and select first of that, because that is that cost me around 0.19 cents per hour. So I can just use that. I've created one, so I will not create that. I will leave that, and you can see that this is my compute cluster which is already running. and I can see the status of my cluster node succeeded. There are 0 nodes. Allocation state time, which is this created on this, and we have some description about this compute cluster, and machine learning compute, and we have subscription ID, we have resource group, workspace region, then we have some resource properties, we have the CPU, which is 2 core 14 GB RAM, 28 GB disk space, and we have processing unit, we have price cost, which OS type is using currently, which we have virtual machine tier dedicated. The current available nodes are 2, maximum number of nodes, and access type is disabled. So we are not just doing some more things about creating a machine learning model. So yeah, let's go to designer. So yeah, first, if you want to like, now we are creating our own personal, our own one machine learning model, but I have already created a one model already, which is in the use. I can just tell about the model how I created that. Okay, just I will first of all go to that model. So yeah, this is the model. So we will discuss about something like why I choose designer, because designer is like easy to create some machine learning models using components. Okay, you can just drag and drop components and just connect that components according to your need, and just like make machine learning model in an easy way. Okay, so you don't need to have some like hard coding in that, you don't need to go some hands on in the hard way. You can just drag and drop components, and you can just make your models in a diagrammatically way, you can say that. So yeah, first of all, the problem is, let's just take a problem. We have to predict some automobile prices. So yeah, first I will do that. First, we need data. Okay, as we talked about in the problem, the first step is to like identify a problem, define a problem. So yeah, in the define a problem, we have we first like defining the problem, what the problem is. We are gathering the data, we are cleaning the data. So yeah, so about this, like up to cleaning missing data is the define the step one, defining the problem. So what we gonna do is like in going to search bar and search for a component, automobile. So what we need some data to process on. As we I search auto, you can see that there is a component called automobile. I will just use and drag and drop that automobile in that. Okay, now I have like I have the data in this. We can see the like day one, just 1 second. We can see what the data is currently right now. On right click, you can just go and right click on that, and then preview data, and you can see that there are a bunch of parameters, bunch of things in that. Symbolic, normalized losses, we have make, we have fuel type. Yeah, there are a bunch of things in that. We have fuel type, aspiration, number of doors, body style, and drive wheels, engine location. There are a bunch of things in that. We have some data to be to create a model to prepare for that. You can see that there are rows, 205 rows and 26 columns. So we have 26 parameter which with particularly 200 to 235 per particular things, per particular cars data, you can say that. Then we go and select select columns in our data set, because we need some like user specified columns. We don't need all the columns from the data, we only need some columns to be data to be processed. So like I will go and type select, and you can see that there is a component select columns in data set. So yeah, I will go and drag and drop that component and just connect data output to this data set. As you can see that there is a like mark, there is a like warning mark. So I will just go and click that. So the warning is saying that you haven't selected a column, so I need to select some columns in that. As you can see that there are some bunch of columns I have selected already. So yeah, I am like you have to basically select all the columns in that. I will just go and show you out how you will select it. Just go to this edit column and column names, and by name you can just go to by name and add all. And this we need to remove one, which is normalized losses. We don't need this in our model, so you can just go and add all these things and save it. And yeah, go to like we have all selected all the columns, so the morning marks is excluded and from that. Now what we need to clean the data. Okay, first we need before converting the data in the 7/3 ratio, we need to clean the data first, removing the outliers. So we need a component for that. There is a component called clean missing data. I just go and to click clean, and here we can find a model, a component for clean missing data. So I will just go and connect this node to this one, clean missing data, and just just take it down. Now the data is clean. We need to select some parameters also in that, so we can see that what bunch of there are a bunch of things we need to like clean it out. And there are three things, there are three parameters which are basically main parameters on which the price can be predicted: the bores, the stroke, and the horsepower. Okay, so yeah, I will just go and add these parameters, and that's like we have to type the bore, the stroke, and the horsepower. Okay, so these are the parameters. You can just go and add these parameters and save in that. And yeah, also if you can see in this, we have some bunch of like I have added this like bore, stroke, and horsepower. Then we have some maximum missing value ratio is 1.0, minimum is 0, and clean mode is remove entire row. So yeah, now we are ready with clean missing data. Now we can just normalize the data. As you can see that in the normalize the data, we are just doing like after cleaning the data, we can normalize the data. We can extracting that selected columns, extracting the particular important data from the missing, from the outcome of missing data. So yeah, so I go to normalize one, normalize data. I will drag and drop this component and just connect this clean data node to this data set. And now it also asks for a bunch of parameters in that. So yeah, the method we will just use for this is minwax, and the use is true. This is by default, and the columns I will just uh, there are a bunch of columns you have to add. So I am just adding this in the chat. You can say that I've added some bunch of parameters and some columns in the chat. Yeah, so these are columns to transform. But all the other things you need to take it by default. These things have to be changed. So yeah, I will use min max in there, and the columns are, so you can just add these columns from to your normalized level data. Then we have split data. We need to convert that data in the 70/30 ratio. So we will just go and use find a split data component and add this component here. And yeah, connect the first node with the split data set. Now we need a model also, because first once the data is processed, the data is like partitioned from with training and testing data set. Then we need to process the data in a algorithm. As you can see, we have a train model component. We need now is the step second, we have to train that model. So we'll drag up two components, which is train model, and we need a model. As this problem is like stating the output, we know that what the output can be. So we can say that the data is labeled. So we are like discussing about a supervised learning problem. So we will use a regression model in this regression, because that is simple to have. So we will just, yeah, we will drag and drop a model, training model basically, which is a linear regression model. So first, in this split dataset component, there are two nodes. The first node is for 70% training, and the second node is 30% testing data. So what I will do that the first like linear regression, there is only one node which is untrained model. So I will just go and drag and drop into this trained model, which is untrained model node. I will just drag and drop this one. And the split data one, the first node which is 70% training, I will drag and drop in the data set. Yeah, so the nodes are connected. Now we have trained model node in that in out as output. Now we have to use a score. Like here is the component with score model, which is score the model on the basis of the like testing data. So yeah, it's a kind of evaluation model, you can say that. We also have evaluation model under there. So yeah, this is the component. So yeah, I will just drag and drop this component somehow here, and I will just connect this node to train model, and the second node is testing 30% testing data. So I will connect it to data set. So this will score our model on the basis of the testing data. Now we need the last component, which is evaluation model, which like finding the correct output from that. So we will just go and select evaluation model component, and we'll just connect the first dot in that. Yeah, so this is your model looks like. If I just minimize all the things, so yeah, you can see that this is a kind of a diagrammatical order of your model which you have designed for automobile price tracking. I just separated from the first model which I have created. So you can see that they both are similar models. First, we will, as according to the first step, which is define a problem. We have our data set. We have our data. Then we have to select columns from that data set. The columns we have specified. Then we have to clean that data, clean like finding the outliers and removing that outliers from the data. Then we have normalized data component, which is kind of like finding the exact like getting the exact input, getting the exact columns from the data, which is the normalized data. Then we have split data, which is not doing nothing but converting, like dividing the data in 70% training and 30% testing data. Then we also have a model which gonna use as a training model. So we have used a linear regression models, which is like simply they're doing nothing but, like, if we place the outputs on a graph. So if we find a linear, like, if we try to draw like graph, if we try to draw a line for the, like, for the outcome, for the output, for that to separate the outputs, we will find some, like, there is a linear like linear relation in that. So that's why we use linear regression. And then we have our train model, in which we have just imported the linear regression model, which is untrained model. And then we have the training data in that. Then we have like output of the train model. We have just done it, connected it with score model, connecting the testing data in that and trained model in that. Now we have last, which is evaluation model, which is evaluate the score on the basis of the data which we have provided in that. So yeah, this is a kind of model. And yeah, let's just delete this one, and let's just discuss about the already created model. In the normalized, you can see that some things are there. Then we have split data. So yeah, so you have to just specify some things in that. In the splitting mode, you can see that the splitting mode is split rows, and fraction of rows in the first output data set is 0.7. I specified that there are 70-30 ratio. You can just take 80-20 ratio also. So as a 70-30 ratio for 70 for training, I just specified 0.7. And randomized split is true. Random speed is 1 2 3. This is I just taken as the random speed. And stratified split is false. So yeah. Then we have some train model. So in the train model, I specified a particular parameter. So what things I need to, like, this model to do. This model is trying to predict the price. So I have just specified the particular parameter in that. I just specified the price in that, the label. Okay. So yeah, the model explanation false, which is by default. Then we have score model. In the score model, the score model is on default. Append score columns output is true. Then we have evaluation model. And whenever I go to evaluation model and right click into that. So first of all, whenever you done with your model, so what you have to do is like name your model for your untrained model. You can say that unprepared pipeline. In this current status is not prepared pipeline. We haven't saved it yet, so we can just name it as a draft. Then we going to save this, and we just click on confirm and submit. So yeah, the first of all, you haven't created a model. You have to create this as a new experiment. You can just name this as a car predicting model, uh, car predicting model, and some kind of thing. And we have job display name, which is auto car, which job we are doing currently, job description. And yeah, keep all the things by default. So I will just specify some meme and just next. This default next. So we have to select our compute cluster. Compute cluster, I have selected Azure ML, which I have created once before. Yeah, so other things are default by default, so you can just go and next and next, and just you can just review and submit this thing. I will just so whenever I just review and submit this thing, so it will take some time. You can see that submit pipeline run succeeded, pipeline job autocar, and this thing. So pipeline job is have been submitted. I can just go and click on view details and see all the current state of my pipeline. So you can see that yeah, whenever the your pipeline is ready, first of all it will go take the data, then process the data on select column in data set, clear, then cleaning missing data, then normalize data, and all the things it will perform. Whenever it will done with it, get all the ticks on that. If it will get the last tick on that, that means the model is correct. Let's check the data, let's check the evaluation results for that. As you can see, there are some bunch of things I have used in that. So yeah, there are some values according to linear regression principles. uh, if this of the if this data is coming under 1, if it is less than 1, that means your model is approximately correct. Not that accurately, but yeah, that's estimated there. That the model is predicting the values estimated as desired output. If it exceeding the 1, that means the you have to just change the model, change the parameters, and just do the iterative process in that. So you can say that coming under 1, that means our model is nearly correct. That is correct in model. So yeah, I can just now we can do this. We get our model, we have created our pipeline, and you can see that. So what I will do that in that scenario, I will just go and create inference pipeline. I will create final pipeline for that. Create inference pipeline, create a real-time inference pipeline. I will just go and click on this. It will take few minutes to process. Yeah, and yeah, now you can see that it created a inference pipeline in that. So I will go to designer, and there are a bunch of inference pipeline. So yeah, this is new one. I will not use that, but I have created on my own, already created a pipeline for this. I will just go and refresh this and find. You can see that there is already a real-time inference pipeline. I will just go and click on that, and I have a bunch of things in that. So, so this web service input component is something kind you will get you will have to get API key, so you can use this model in your web applications. So yeah, that this will gather a data from your web service request and just process the data in this current inference pipeline, current model, and then output the data from the web service output. So yeah, as now I will just add some bunch of things. I have added enter data manually, so I can just add some data. I will add in this into the chat box. So this is the kind of manual data, so some raw data which we gonna use as a to test this model on which. So this kind of CSV data. So we will just do enter enter data manually. We will find a component for that, and yeah, enter data. We'll just go and drag down and we'll try to find that component. As you can see, there is a component which is enter data manual. I will drag and drop this component and just connect this component with this select columns in data set data, and just add the data, like add your raw data in that as a data, and data format will be CSV. And then add this select this node and just connect it with select column in data set. So it will take it will not taking currently not we are not using web service input, but we are just trying to inserting the data manually on ourselves. Then we are just adding that into the column, select columns in data set. Then we have some bunch of things. We apply transform. This is all part of inference pipeline. Then we have last, we need to like, we need to add a and we need to add a script in that. I have created a script for that. I'm adding that in the chat. So what you have to do is, whenever the model, like whenever your inference pipeline is created, then go to score model, and you here you have to add a component. So you can just execute Python script in that. So I will just execute Python's, drag and drop this component here, and connect it with the score model, and the data set one. And here I will like, delete all the, and I provided a Python script for that. I will just go and add that Python script. This will do that, show the output in a meaning way, as as desired, as we have inserted in the script. Yeah. So and connect the resultant data set to the web service output, that will as by default. So this will your inference pipeline will look like. And then whenever your inference pipeline is ready, you can just go to pipeline jobs. You can just like cancel it. I don't need to save any changes, so I will just confirm it. And yeah, I will go to jobs and find the inference pipeline here. And yeah, so this is the, like, I have created a new one model in that. So this is showing that I will go to designer and predict auto price. If you are if you are new here, you will find a deploy option here, as I have already deployed it. So I'm not getting a deploy option. This is a validate option already. The pipelines low code you can submit or publish now. So yeah, let's see the deployed one. I will go to models, and here you can see that one model is currently deployed in a deployed state. And you can see that name of the model is, and version, which version is currently in deploy, which currently deployed, which is production, and created on creator name type of model is. And yeah, you can see the versions of this model, as I've created only one and doesn't make any changes in that. So this is the version one is currently in production. And then we will go to endpoints, and here is the bunch of things. As you can see that my deployment state is healthy right now. Whenever you deploy your model, so it will take some time. Okay, not at that particular time it will get deployed, but it takes some time to get in the healthy state. Okay, so healthy state is basically mean the this particular model is deployed and the model is correct and can be able to predict some data. Okay, so you can see bunch of things in that. So yeah, this is the rest endpoint you can use in your application. And I will go to test, and there are a bunch of things. V1 deployment testing not supported. And you can see that this deployment is based on V version 1 API and doesn't support testing on Studio. To get the key token invoke, please use ELI and REST version 1. We need to migrate it to version 2. There I need some another version for this. So that's why we have deployed this model. We can use this model on our web applications using the REST endpoints and API keys. We can go to Azure platform and create an API case for that. So yeah, this is a introduction to Azure machine learning platform. We have created a model. And stop sharing. I will just let's just open the PPT right now. So yeah, the PPT is open. So we have talked about like different services which we can use to create our machine learning models, to manage our machine learning models, to create a pipeline. We created a model step by step. We followed all the steps. We created a model, entering the gathering the data, gathering the columns from the data set, cleaning the data, cleaning missing data. Then we are normalizing the data, selecting the model, untrained model, and we will going to use the training data and model to predict the to train the model, basically to create the program. Then we have created a real-time inferencing pipeline from that model, from the model we prepared, we tested, and that. After that pipeline, we also take the things, we've also process the data and see that the what the desired output can be, what if the model is correct or not. Then we also deploy that model in the production and see all the things, we how we can use that in our web applications in a further way, how we can create our the rest API endpoints and that things also. So yeah, that's all for today. That's all for today for this session. So there are a bunch of things also. So I'll request you to scan this QR code, and there is a 2 question survey. You can just fill and give some feedback on this session on the MLSA program, on the Microsoft Student Ambassadors program. So yeah, I'm providing this for just 5 seconds, and then we will move on to that's another thing. So yeah, I hope you have scanned this QR code. Then this is for vouchers, as I talked about. If you want to get hands-on, what I have talked about, what model, what data I have used, and what things I have practically taught you, you can just go and get a voucher. You can just scan this QR code and fill a form. And through your mail, in like one day, I will sign the voucher code with your mail. So you have to just request for Azure voucher. Okay, so you can just request for that voucher, and using that voucher you will get some like 100 USD credits for your Azure platform. You can just use this credit to create machine learning models, and use the deploy your models and create computers, do anything in that. So that's all for today. For more info, you can connect with me on LinkedIn, and you can just tag me and pin me on LinkedIn. You can just find me, or you can just go on Google and search for my name, Aditya Attkan, and you will find my all social profiles for LinkedIn, Twitter. And you can just, if you have any doubt regarding session, if you have any doubt regarding some other things in the Azure, in not in the Azure, or in other things in the tag field of web development, you could just ping me. Yeah, ping me on the LinkedIn, ping me on the Twitter, and just ask what a curious mind expecting to have. Okay, that's all for today. Thank you with connecting with us, and yeah,